how we can express this particular integrand, right? Or how we can integrate this particular function we have right here. Okay, so from here, we know that e power t inverse or e exponential function power tan inverse of x, right? We can integrate this straight away, right? Or we can decide to change this from a fraction to multiplication, right? By changing this to inverse, right? So we can say that this is the same as e power tan inverse of x into 1 plus s squared power -1 dx. Or we can forget about this and also say that integral e power tan inverse of x all over 1 plus s squared dx. We should try to use what we call the u sub or the u substitution. Okay, so we can say that let u equals tan inverse of x, right? So differentiating both sides, then we have the u equals, tan inverse of x. When you differentiate, it's going to have 1 over 1 plus s squared. Then you differentiate the inside, which is the x, and that is going to be 1. So you forget about that. Okay, so we have this here, the x. So let's try to make the x the subject. Okay, so we can say that the x is equal to 1 plus s squared du, right? So we have this information here. So let's do back substitution and see what we're going to have. So we have integral e power. Now tan inverse of x is u all over 1 plus s squared times, now our dx is 1 plus s squared du, right? So this, take care of this, and we're going to have e power u du, right? And well known that e power u, when you integrate it, just an exponential function, when you integrate it, it remains the same. So you're going to have e power u plus our constant of integration. But don't forget that u was tan inverse of x. So finally, you're going to have e power tan inverse of x plus a constant of integration. So this becomes the final answer to this particular problem. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye-bye.